Hey guys, here are the videos for tutorial 8. So the first 3 problems are all very similar. So I'm going to focus on problem 1, and I'll give you a little bit of information on problems 2 and 3. And then problem 4 is really a category by itself. Okay, so for virtual work, there's really no shortcut. You have to do a lot of work for virtual work. Virtual work is very flexible, but it comes at the cost that you have to do. You have to analyze quite a few things in order to make use of it. The advantage is that you can apply the same set of rules for virtually any problem. So once it's not like moment area where you have to be careful with the initial slopes and the initial deflections. For virtual work, you can, once you have your diagrams, you can find the deflection pretty much anywhere. So I'm going to start off with number 1, like I was saying, and just very quickly, I want to make sure that you guys at least get the reactions correct, because without those, you're going to be quite lost. So if we have some system that's like this, 200, 400, and you can get these dimensions all on your sheet of paper, but if we take the moment, if we're trying to find dy, then we're going to get 200 times 5 plus 400 times 4 plus 200 times 6 equals dy times 8. dy will be 550 kilonewtons. Ay will be 50 kilonewtons. These are both going upwards. And ax will be equal to 20 kilonewtons to the right. Okay, so those are your reactions. Now, for a truss, you have no bending. You have only axial forces in every single member. So we're only going to do an axial force analysis. And this is true for problems 1 and 3. Number 4, you have both axial and bending. So you don't ignore axial. You have to include both axial and bending. But we'll discuss that later. So to start off with, you have 5 members. You need to find the force in every single member due to these 3 loads. These 3 loads will represent your P system. So I think it's good practice for you guys to figure out how to get the loads in a truss yourself. It should be quite familiar for you. I believe that is one of the simplest things you guys learned this semester. You look at it. If I'll do the forces of joint C. So we have 200, 200, FBC, and FCD. If we do sum of forces in the X, we get FBC times 4 on 5. It's given by the ratio of triangles, the ratio of the sides. That equals 200. FBC equals 250 kilonewtons. And that is in tension. FCD, by a similar process, will turn out to be negative 350 kilonewtons, or 350 kilonewtons in compression. So it's always depending. I would stick with this for now. Stick with that for now. Okay, so I just found these two forces. You want to find the other 3 forces. So you want to find FAB, FAD, and FBD. I think he introduced this table in class, but let me zoom out a little. Okay. You're going to want to create a fairly large table. So this is going to be your members. And this is going to be length AE FP. So these forces, the forces due to your original load, are what we call the P system. So that's what I'm putting in the FP column. We need one Q system for every direction and deflection that we're interested in. We're interested in the deflection at 2 points and in 3 directions total. Horizontal and vertical at C, so that's 2 deflections, and horizontal displacement at D, so that's 3 deflections. So I will need 3FQ. I'll call this FQCX, FQCY, FQDX. And the professor wrote down these tables differently, I'm assuming, but you can, as long as you get all the information in there, it doesn't matter how you write the tables. The important information you need is everything to get in here. So you need a column for each one of these and an extra column for every deflection. So we have A, B, B, C, A, D, B, D, C, D. We have 5 members. I'll just give you the length. The lengths aren't that hard to figure out. B, C, and A, B are both 5. A, D is 8. B, D is 5. C, D is 6. AE are the same all the way down. AE, if you work with E in gigapascals, 1 gigapascal is the same as 1 kilonewton per millimeter squared. So there's no need to change the units on this. So if I do AE, that is just 250 times 200. That equals 50,000 kilonewtons. So I don't need to do anything with the units here. I can just keep it in terms of 50,000, and I just put an arrow going all the way down to indicate that that is all of them. I didn't give you guys the forces for all the members, but the 2 members that we do have are FDC or FCD equals to negative 350. And up here we have FBC equals to 250. So those are the things that we know so far. Okay, so with that, I need to find this Q system. I'll get you started with FQCX. So I'll help you fill out this column. You'll need to fill out the rest of the information in this table by yourself, but I'll help you with this FQCX for now. So let's zoom back in. If we're working with FQC, if we're interested in the deflection at CX, all we have to do is we ignore the original loads and we apply a unit load at C in the direction of X. So we just have, let me use a different color here. Where did my markers go? So FQCX, we have this truss, and we apply a unit load of 1 here. And we analyze for every single member force inside this member. If we look at the same member up here, at the same point, this is C, FBD, FCD, and this is 1. We'll get the FBD is equal to, and you can use geometry to figure this out, but this is FBC. FBC times 4 on 5 equals 1. Therefore, FBC equals 5 on 4. I'm looking at that and I think that's correct. FBC equals 5 on 4. FCD equals a negative 3 on 4. We do this for every single member. So I only did it for these 2 here, but you have to do it for all 5 members. You go back in here and plug in. So we were doing this with the unit load applied at C in the direction of X. We go to that corresponding column and fill in those rows. So this is 5 on 4, and this is negative 3 on 4. Okay, so I have that. I would do that for every column. So for FQCY, I would do this. And for FQDX, I would do this. Okay, so that is pretty much everything. I would fill all the member forces into this row, all of these member forces into this row. When I'm done with that, I would then have 5 filled out rows, right? Some of the numbers might be 0, but I would have 5 rows. And what I would do is I would just plug in, I would multiply everything in going across. So for example, I would multiply L, F, P, F, Q, C, X on A, E for A, B. For B, C, I actually did this one already, so I can do that here, and I should use green consistently across this, I'm sorry. This is for delta C in the X direction. I would do length, which is 5 meters, times FP, which is 250 kilonewtons, times FQCX, which is 5 on 4. Divide that by 50,000 kilonewtons. So they're all in the same units now. Length is in meters. That is BC. I would do the same thing for AD, plus the same thing for BD. And then I would be left with plus 6 times negative 350. So the negative signs will cancel out here. And I'm just doing the same thing that I was doing before. And this total deflection, when I add up, I'll plug in the terms into this equation, plug in terms into this equation, and this one, this one, this one. I'll add them all up. Some of them might be positive, some of them might be negative, but I work with the signs that I have. And I add everything up, and I'll get some deflection. I'll get that delta equals some number. This will be either positive or negative. If it's positive, it means the deflection is in the same direction as the initial arrow that I drew for the QCX diagram. So if it's positive, that means that my deflection will be this way. If it's negative, that means that my deflection will be going in the opposite way. So that is how you interpret the signs. And so you do have to be very careful with the signs on this problem, or actually when using virtual work at all. If you add and subtract things that are not meant to be, that are of the wrong sign, then you'll end up either overestimating or underestimating your deflections, which will be very bad. It says to check your work with SAP 2000. Some people were having license issues with that. If you have a license issue, email Naveed. We'll play a little trick on Naveed. Email Naveed. Naveed is in charge of the licensing issues. And then hopefully he'll send out an email. Yeah, okay, so I think I went through that a little bit quickly, but I'm hoping that everything is clear. If you guys have a question, feel free to email either of us on this problem. And I'll try to figure out, I have not managed to check the solutions that I have yet. So I'm not sure what deflections that are ultimately correct here, but my preliminary deflection for number 1, let's do dx. Right now, I have that dx equals 4.3 millimeters, and I think that's to the right. That is, yeah, to the right, that way. So you should get this one, and then that'll be a good reference for you guys. So if you don't get dx, then make sure that you're doing the procedure correctly. Okay, so you might want to start at dx. Email us if you have any questions.